So we're starting with a pretty easy assignment here, but also very important as we get into the word problems. We're going to be creating different points and things and trying to write our equation to model the situation. But in order to model the situation, we do have to kind of get an intro to these word problems. Understand what are they talking about when they mention certain things. So here we go. A piece of gum is stuck to a tire of a bike wheel in motion. Kind of gross. The vertical distance between the gum and the ground in centimeters is modeled by h of t. So this is the distance between the gum and the ground. You can see as it goes on the wheel, it touches the ground and goes around again, and then touches the ground and goes around again, and that wheel is the exact same height. So you see this kind of perfect situation. As long as you're maintaining the same speed, these will be, the same distance each time. That's what we're doing in this perfect situation here. So the function graph below along with one highlighted segment. So what they're highlighting here, we know, is right in the middle. That is the midline, right? So you can kind of picture the tire. We have a bike tire, and then you got your spokes. Ooh, everything is going great until I did that one. And we have a piece of gum. So right here you can see when it's on the top of the tire, that's the top here. When it's on the bottom of the tire, it's on the ground. And then the midline would be right in, the middle. And that's why it goes through it. Look at that. Before it touches the ground, it goes 2 times through the middle, because right here, and then as it goes around right there again, is on the middle of that tire. So let's see. Right here, which key feature? We know it's the midline. All right, we're good. And then, what is the meaning of this, the highlighted segment? So the diameter of the wheel is 30 centimeters. Well, it doesn't really have to do with the diameter, right? That's just it's the midline. The bike speed is 30 centimeters per second. So the midline, I don't think is telling us the speed. The wheel center is 30 meters above the ground. Now, I think that's what it's talking about, right? Midline is probably talking about the wheel center and it being 30 meters. So that height, when the gum is right there, is going to be 30 meters. So that's where the wheel center is going to be at, because that would be the same height as the center of the wheel. And the wheel completes a single cycle in 30 seconds. No, it's actually doing a cycle in, looks like 2 seconds, but that would be the period, if we're looking for that. Okay, Sia is swinging from a chandelier. The horizontal distance between Sia and the wall in meters is modeled by d of t, where t is the time in seconds. So right here we have a wall, and somebody is hanging on a chandelier. Not sure how to even draw that. It wasn't that bad, actually. So, he had drew 4 arms. There we go. So d of t is the distance from the wall. So that's going back and forth, right? So starting, this right here is the amplitude. That's the distance from the middle. So there's your midline, but what they're giving here is the amplitude. So when she's furthest, this is when she's, no, actually this looks like when she's closest to the wall. It's the lowest number, distance is the least. So when she's closest to the wall in the middle, the difference between that. So we know it's amplitude. Let's see what it means in this. So Sia completes 2 swing cycles per second. That's more like the, that's more has to do with the period, right? The chandelier is hung 2 meters from the wall. So, okay, that might have something to do with it, because if you look at this is a distance of 2, right? And that's the distance. Here's the, well, I don't know about that. I think it's hung 5 meters from the wall, right? This would be where she comes back to the middle, where the chandelier is hung. So that's kind of close. The chandelier is 2 meters wide. I don't know about that. The furthest Sia gets from the point where the chandelier hangs is 2 meters. Now that makes sense. See that this is where it hangs, where the green line's at, and the furthest she ever gets from it is 2 meters. That makes sense. That's the amplitude. And the closest she gets to the wall is 3, because the wall would be right there on the x-axis. Ballerina is spinning while standing on one leg, so the point that is furthest from the center of her body is her other knee. The horizontal distance of the ballerina's knee and the edge of the stage is modeled by Okay, so I'm just going to look at this real quick. This is the period from the bottom to the other bottom. That's the period, right? So what does that mean? Ballerina completes one spin in 0.4 seconds. Look at that. So that's a spin around, right? Spin around, that's one time. There's another time. There's another time. So how long does it take one? 0.4. That distance there is 0.4. So I'm going to say A, completes the spin. And double check the rest. The center of the ballerina's body is 0.4 meters from, no, the center is probably the midline. The center of the ballerina's body from the edge of the stage, probably talking about, that's the distance, that's probably the amplitude there. And then the ballerina completes 0.4 spins in 1 second. No, it's more like she completes that spin in 0.4 seconds. So they're trying to trick us there.